Welcome to The Explainer. Today, we're diving deep to uncover the secret sauce inside your graphics card. We're talking about these tiny, specialized engines that are totally changing the game for our computers.
Have you ever stopped and wondered what makes modern games look so, well, real? Or how those new AI tools feel almost instantaneous? I mean, really think about it. The leap we've seen, it's not just about making the old stuff faster. No, something fundamental has changed deep down in the silicon. And the answer? It's all thanks to this brilliant shift in design.
So, let's talk about these specialists. For the longest time, the whole idea was to make general-purpose cores that were, a jack of all trades. They could do a little bit of everything. But then came the demands of modern computing. We're talking intense AI, hyper-realistic graphics, and that old approach just wasn't cutting it. So chip designers pivoted. They stopped building jacks of all trades and started creating masters of one. And this right here really breaks it down perfectly. On one side, you've got your traditional general-purpose cores. Think of them as the reliable workhorses of the GPU, super flexible, ready for any task you throw at them. But then, on the other side, you've got the specialists. And these guys, they are not flexible at all. They do one job and one job only, but they do it with just breathtaking speed and efficiency. All right, let's meet our first specialist, the Tensor core. The best way to think about this is like a tiny, hyper-efficient AI math factory right there on the chip. Its entire job, its whole reason for being, is to do one single calculation over and over and over, matrix multiplication. And what do you know? That just happens to be the mathematical bedrock of pretty much all modern AI and deep learning. So when you build a dedicated factory just for that one task, well, the performance you get is just incredible. And our second specialist is the RT core, which stands for Ray Tracing Core. And I gotta say, I love this analogy. It's basically a light ray detective. Its only mission is to figure out exactly where a virtual ray of light hits an object in a 3D scene. This one little job is the absolute key to creating those mind-blowing, realistic reflections, shadows, and lighting effects that, not too long ago, were something only Hollywood movie studios could pull off. Okay, so we know what they are. But the big question is, how? How do these little specialists actually get so ridiculously fast? Let's peel back the onion one more layer and look at the simple but frankly brilliant mechanics that make them tick.
So for the Tensor core, the magic is all about efficiency. It's a super simple process, really. It grabs two big grids of numbers. Then, in a single go, it does what's called a fused multiply-add, basically multiplying and adding them together all at once. It even uses this clever trick called mixed precision to get maximum speed without messing up the accuracy. The whole thing is just perfectly engineered to do that one sequence instantly.
The RT core is just as smart about its job. Imagine a super complex 3D scene with millions of tiny triangles. Instead of checking every single one, which would take forever, it takes a brilliant shortcut. First, it just checks if a light ray hits a big, simple box drawn around an object. That's a super fast check. Only if the answer is yep, it hit the box, does it then bother to do the hard math to find the exact pixel it landed on. It's a simple two-step check that saves a mind-boggling amount of wasted effort. Right, so we've established we have these tiny, super-efficient specialists living on the chip. But so what? How does that actually change what you and I see on our screens? Well, this is where it gets really interesting. We start to see this incredible ripple effect, a wave that starts in the silicon and just spreads out across the entire tech world. And let's kick this off with the most important number of all. We're talking a speed increase of 10 to 100 times. For their specific jobs, these specialized cores are 10x to 100x faster than a general-purpose core trying to do the same thing. I want you to let that sink in. This isn't a small bump. This isn't an incremental improvement. This is a complete revolutionary leap.
So let's follow that chain reaction, right? At the most basic hardware level, you get way faster calculations. That, in turn, gives you higher frame rates and faster data processing. Okay, cool. But then that performance unlocks entirely new features that just weren't possible before. Things like real-time ray tracing or AI upscaling like DLSS. Zoom out to the industry level, and this is the hardware that makes training gigantic AI models even viable. And where does it all end up? It ends up with you, getting more realistic games and running crazy powerful AI tools right on your own PC.
So here's the bottom line, the big takeaway. This isn't just about speed. It's about enabling features that were literally impossible in real time before. That huge wall between what a Hollywood studio could render over weeks and what your computer can create right now, yeah, that wall has been completely shattered. Okay, I know this can sound a little abstract. Silicon, cores, calculations. But I promise you, this stuff has very real, very practical effects on how you choose and use your tech every single day. Think about it. When you go to buy a new GPU, you're not just looking at clock speeds anymore, are you? You're looking at its Tensor and RT core counts. In your games, these cores are the reason you can flip on that ray tracing setting and just watch the world transform. They're the reason you can download a powerful AI image generator and run it on your own machine, no cloud required. And if you're a creative, wow, this is the difference between a project rendering for hours or just a few minutes. It's a total game changer. But of course, in engineering, there's no such thing as a free lunch, right? This amazing power comes with some pretty significant trade-offs. For one, these cores are specialists. They're completely useless for anything outside their one specific job. And if the software you're running isn't built to use them, well, they just sit there taking up space. Plus, cramming all this extra specialized hardware onto a chip, that makes things more complex and, you guessed it, more expensive.
And that brings us to a final really exciting thought. So far, we've seen these specialized cores for AI and for light. But you have to believe this is just the beginning of this trend. So as designers keep pushing this idea, building more and more specialized hardware for more specific jobs, what's next? What's that currently impossible feature that's just waiting in the wings for its own dedicated core to make it a reality? What's the next thing that's going to jump straight from science fiction to your screen?